Hey, and welcome to the first day of Unit 2. Unit 2 is on the lithosphere, all right? And the lithosphere is just a name for the top layer of the Earth, all right? It's the part of the Earth that we're the most familiar with. Every rock you've ever seen in your life comes from the lithosphere, all right? The first day, today we're going to be talking about something that you know a little bit about, which are rocks, all right? Specifically the rock cycle. All right, and the rock cycle is just a process where rocks on Earth can get turned into other types of rocks. All right, so before talking about this, we need to introduce the three major types of rocks that exist on Earth. All right, those are called igneous, sedimentary, and metamorphic rocks. All right, and what makes the rocks what they are is how they get formed. All right, so the first one we're going to talk about are igneous rocks. All right, so what makes a rock an igneous rock is the fact that it's a type of rock that gets formed whenever melted rock cools. All right, so if you've ever seen video of a volcano erupting, you might be familiar with lava running down the side of the volcano. All right, and when that lava, which is just a form of melted rock, when it cools, it's going to harden and become a rock. All right, so that is a classic example of an igneous rock, but there are other types. All right, so igneous rocks are rocks that are formed from the cooling and crystallization of magma, which is melted rock underneath the surface of the Earth, or lava, which is melted rock on the surface of the Earth. All right. So the two major different types of igneous rocks are intrusive igneous rocks and extrusive igneous rocks. And what makes these different is where they form. All right. An intrusive igneous rock is formed whenever melted rock solidifies underneath the surface of the Earth. All right, and because it's melted rock underneath the surface, we would call that magma. All right. By contrast, an extrusive igneous rock is one that's formed when lava on the surface of the Earth cools and makes a rock. All right. So the most common example of an intrusive igneous rock is granite. All right, and granite if this looks familiar, it's because you might have seen it in different locations. In fact, I'm going to show you a bit of it right now. All right, so I've taken a few steps over here into my kitchen, and there's my toaster and coffee maker. But if you take a look at the countertop right here, all right, that countertop is made of a material that a lot of countertops in this in new housing are made of. This stuff right here is actually granite. It's the exact same type of rock that I was just showing a second ago. And you can see those little black flecks that are in that. So that's one of the types of minerals that's common in granite. But the interesting thing is, like, when you look at any granite countertop like that, the place that this rock right here was actually made was underneath the surface of the Earth. All right, that used to be melted rock deep under the surface of the Earth, and it cooled probably millions of years ago. It made that rock, and then recently someone was able to harvest that up mine that out of the ground, and then cut it into sections that people could then turn into their countertops. So one thing about intrusive igneous rocks is that since they form underground, the rocks are formed from really, really slow cooling of that liquid rock. All right, and that means that you get relatively large crystals. All right, so if you take a look at a close-up of some granite, you can see these actual different areas. All right, you've got this black area right here, you've got this whitish area, you've got this pink colored area right here. And in order for these types of things to form that you can actually see with your naked eye, that requires really, really slow cooling of that liquid rock. All right. Um, so in contrast to an intrusive igneous rock, which forms underground, we also have extrusive igneous rocks, which form on the surface of the earth. All right. Classic example of that is going to be this rock right here called pumice. All right, and this forms, from lava that gets shot out of volcanoes. All right, you'll notice that there's a lot of holes in it. All right, and one thing that pumice is famous for is that it's the only rock that will float on water. All right, so if you had that took this rock and threw it into a pool, it wouldn't sink. All right, some people might recognize pumice because it's if you've got a barbecue grill, all right, the rocks that they put in barbecue grills are pumice. All right, sometimes some people have a pumice stone. All right, you'll see them as something that you can rub against your skin, and it'll kind of rub off some of that dead skin. All right, but the thing about this is that since it forms on the surface of the earth, it cools really fast. All right, and because of that, you're not going to get very large crystals. So if you look at this rock right here, you don't see you don't see crystals in it in the same way that you would the granite up here. The next type of rock is a sedimentary rock. All right, so a sedimentary rock, these are rocks formed from when tiny pieces of existing rock come together. They've been broken into small bits, and they've been transported, they've been deposited, and they've been kind of compacted and pressed together and cemented together to make a new rock. All right. So there's two processes that occur. The first is compaction, which is the process where all the different tiny rocks are squeezed together, and they're squeezed together because they're buried underground. And when things get buried underground, the weight of all that dirt on top of it presses down, and that really makes it, and that forces the rocks to come together. All right. The other thing that's needed is cementation. All right. So what I tell people a good thing to remember when you think of sedimentary rocks is to think about a Rice Krispie treat. Okay, so hopefully you're familiar with the Rice Krispie treat, but essentially, like the way that these things are made, they're made originally starting from a bunch of tiny little Rice Krispies. All right, and what you do is you put those in a pan, and then you pour this sugary goo on it, and you press them down hard. All right, and so the thing about it, you press them down so that it squeezes them together. And then you've got this cement between them. That's the marshmallow stuff that makes it all bind together. And then when you're done, you have these pieces that all stay together. All right. But the thing about a Rice Krispie treat that I think most people know is that if you look closely enough at it, you can still see the existing Rice Krispies that went into the Rice Krispie treat. All right. So there's tiny little Rice Krispies in this right here. All right, so sedimentary rock kind of works the same way. So these rocks right here, at one point in time, they were tiny little rocks. All right, this right here is sandstone. So at one point in time, it was just tiny pieces of sand, but it got buried and it got forced together. It got compacted, and there's also some chemicals here that help to hold the rock together, and that's how this got formed. The last type of rock is a metamorphic rock. All right, and metamorphic rocks are rocks that get formed when the rocks get buried, and when they get buried deep enough and you put enough pressure on them and they get exposed to heat. All right, when you get deep enough into the earth, it gets really hot. But when they get exposed to heat and pressure, they're going to change. All right, so one thing about metamorphic rocks, they don't melt. All right, so even though they're underground and they're heated and put under pressure, they don't actually melt, but they stay solid, but they turn into a different form. All right, so there's two major categories One is foliated, all right, and that's when you can see the different layers that are in the rocks. But there's also non-foliated, all right. So a very common example of a metamorphic rock is going to be marble. So the thing about these kind of rocks is they don't stay like that forever. Rocks are constantly being turned into different types of rock. And the thing is, it doesn't happen quickly. Some of this can happen over millions of years, all right? But like if you consider the age of the Earth, that's enough time for these rocks to be recycled and turned into different things, all right? So let's say that let's say that we start off with magma, all right? Some melted rock, all right? Well, that can cool, and that can form igneous rock, all right? But then that igneous rock could get broken down into smaller bits, sediments. And those sediments can then get squeezed together, all right, and cemented to make sedimentary rock, all right? If you have that sedimentary rock underground, if you put even, if you subject that to heat and pressure, if you heat it up and you press it even more, that can get turned into metamorphic rock. And if you keep on heating that, it'll eventually melt, all right? And so the cycle could go around in that direction, all right? But there's a couple of other things that could happen. For example, that metamorphic rock, it could get, forced up to the surface where it could get broken down into sediments, and then that could get turned into a sedimentary rock, all right? You could also have a situation where an igneous rock could get buried, all right, without getting broken down and get turned directly into a metamorphic rock, all right? So all of these are possibilities that can happen, and this overall cycle right here is what we refer to as the rock cycle.